So we remember this problem with the box sliding down the inclined plane, frictionless or with friction. And we remember there were two different ways that we could solve it. Using dynamics, with this vector sum of the forces equal mass times acceleration. And we can split that into two directions. The parallel direction, we picked this because this is a direction of the acceleration, and the perpendicular direction where the acceleration in that direction is 0. Now we keep in mind if this is h naught, and if you're careful with the measurement, you'll see that this is only about 5% longer. And down here is about 30% h naught. As you split the force of gravity into the parallel and perpendicular components, you'll find that the acceleration downward in a frictionless environment is about 9.5 meters per second squared. Don't believe me, check it. And that the normal force pushing out to compensate for the perpendicular component of gravity is about 0.3 times the weight, or 0.3 times mg. And if you wanted to look at friction, you'd throw friction in here in the parallel direction. Then we looked at energy. Energy is beautiful, I think. Where we could say the potential energy changes to kinetic energy, and this would give us V final. And from V final I could get the average velocity, and then the amount of time it takes, and I could find acceleration. It's a lot of kinematics. Most of you agreed you didn't like this way. It was more work. So I asked you, what if we could use energy and no kinematics, and I could solve it in one line? Would you like that better? I say, look, the potential energy, it goes to kinetic energy of the block. But the kinetic energy that the block gains is equal to the work done on the block. And so this just is equal to the work done by all the forces on the block. And we know what that is. Work is just force times delta x. So we're only looking at the parallel forces, and we're moving in the parallel direction. So the dot product vanishes, and it's just a straight up product. And we know what force is. It's mass times acceleration, and this is 1.05 h naught. And so the potential energy turns to kinetic energy, or the potential energy turns to work on the block, and that's just mgh. And so we love it because this just cancels, and this cancels, and we find that the acceleration is just equal to g over 1.05, which is about my 9.5 meters per second squared. Do you love that? Now you say, what about friction? If I added friction in, then you just say, oh, well, the total work done on the box is going to be that potential energy minus the work of friction. Or the mechanical energy turned to thermal energy through the mechanism of heat. And then you find your acceleration is, of course, less than 9.5 meters per second squared. Just sharing.